దీన్ని పెడితే సౌండ్ వస్తుంది. Good morning, students. In the last class, we had discussed about the surface chemistry. In that surface chemistry, the major points are: one is adsorbent, another one is adsorbate. So, those adsorbent molecules are deposited on adsorbate. It is called as adsorption. So, based on the adsorption phenomena we are discussed the terms of adsorption. One is sorption, desorption and absorption, and after that physical adsorption, chemical adsorption and adsorption influencing parameters we are discussed. In that adsorption influencing parameters, one is temperature, another one is pressure. So, in that pressure influencing factors are, one factor is present, that is Freundlich adsorption isotherm. Here Freundlich adsorption isotherm, here one word is there, isotherm. Iso means same, therm means temperature. If same temperature condition, and how the adsorption phenomenon will be takes place, that is called as Freundlich adsorption isotherm. This Freundlich adsorption isotherm is applicable for physical adsorption only, whereas Langmuir another adsorption isotherm is also there. That another adsorption isotherm is Langmuir adsorption isotherm. Freundlich is one of the scientists, Langmuir is also another scientist. Here the basic difference is Freundlich adsorption isotherm for physical adsorption phenomenon, it is explained by Freundlich scientist. Chemical adsorption phenomenon is explained by Langmuir scientist. This is the major difference. In the earlier class, what we are discussed about that physical adsorption and chemical adsorption. What is the physical adsorption means? The physical adsorption will have the weak attraction forces will be there. What are the weak attraction forces? The attraction forces are called as van der Waals attraction forces. Those attraction forces are very weak, so it will be form multi-layered system. I am taking the one of the example as a duster, and after the duster and chalk powder, it forms as in a multi-layered system. Whereas in the chemical adsorption, formation of rust formation or accumulation of hydrogen on the surface of the nickel, palladium, platinum. Nickel paina kaaniyandi, లేదా పల్లాడియం పైన కానివ్వండి, ప్లాటినం పైన హైడ్రోజన్ గ్యాస్ డిపాజిటెడ్ ఈజ్ కాల్డ్ యాజ్ అక్యులేషన్. సో దట్ ఫినామినన్ ఈజ్ ఎక్స్ప్లెయిన్డ్ బై కెమికల్ అడ్సార్ప్షన్. When chemical adsorption is there, the strong attraction forces will be there, so the van der Waals forces are strong. Now here isotherm, iso means same, Thermal means temperature. If the same temperature curves are present, that is called isotherm. This will be explained by Freundlich scientist. According to Freundlich adsorption isotherm, X gas of the material means we have to whatever the adsorption phenomena means, one is adsorbent, another one is adsorbate present. So, X mass of the material deposited on M mass of the adsorbent. X mass of the material is deposited on M mass of the adsorbent. So, that is X by M is directly proportional to P. Means P means whatever the pressure, X means X mass of the gas. You can take any gas, either easily liquefiable gas or whatever the gas, hydrogen gas, nitrogen, oxygen, carbon monoxide or carbon dioxide, whatever it may be. According to the Freundlich condition, at isotherm means at constant temperature. At constant temperature, what happened? The amount of gas adsorbed. How much amount of gas adsorbed? X. X mass of the material deposited on M mass of the adsorbent. So, that is directly proportional to P. If we are removal of the proportionality sign, we have to take whatever the one of the constant, that is X by M is equal to K into P. Here depend upon the condition how much amount of the material is deposited. The deposited materials are what we have to take is a one of the range it will be present. That range we have to depend upon the pressure, the range is 1 by N. Here the range is 0 to 1. Here the N value, N range is 0 to 1. Here depend upon the pressure condition. Depend upon the pressure condition, what happen, whatever the material will be deposited on the surface of the material. If more amount of pressure we have to create, the molecules are closer to each other, automatically adsorption rate will be increases. So, X mass of the gas deposited, M mass of the absorbent. So, X by M is equal to, that is removal of the proportionality sign, K into P to the power of 1 by N. If you are taking whatever the logarithm value, how we have to represent means log X by M equal to, log X by M is equal to 1 by N log P, 1 by N log P plus log K, 1 by N log P plus log K. So, this is according to whatever the y is equal to mx plus c condition it will there. So, y is equal to mx plus c graph it will be takes place. If you plot a graph, x axis we have to take as the pressure condition and y axis we have to take x by m. X by m means adsorption material, and here what type of slope we are getting means, here we are getting the positive slope it will be there. The intercept value is whatever the log k it will be takes place. The intercept value it will be takes place as log k. So, that one is here log k it will be takes place. Means this here in this range means if here more amount of pressure is applied, automatically Freundlich adsorption is not applicable, because of physics it is the only phenomena physical adsorption. More material, more amount of material is deposited, multi-layered function it will be takes place. So, that is Freundlich adsorption isotherm. According to the Freundlich absorption isotherm, if 1 by N value is equal to 0, 1 by N is equal to 0, then X by M is equal to whatever the constant. 1 by N is equal to 0, X by M is equal to constant. If 1 by N is equal to 1 and 1 by N is equal to 0 condition, it will be variable, it takes place. So, this belongs to whatever the Freundlich adsorption isotherm. Major here phenomenon is what? Freundlich adsorption isotherm is belongs to physical adsorption only. Next, another one is if you are creating high pressure, automatically this Freundlich adsorption isotherm phenomenon is failures. Only moderate pressure condition only Freundlich adsorption isotherm. If exceeds the pressure, that whatever the desorption will be takes place, due to that reason adsorption phenomena we cannot explain at the high pressure. Only moderate pressure condition or low pressure system condition only that Freundlich adsorption isotherm is there. So, this is the whatever the principle for different type of calculation purpose we are using. Log x by m is equal to 1 by n log p plus log k. Here the constants are k and n values are constant, and x by m is adsorption phenomenon it will be takes place. Freundlich adsorption isotherm is applicable for only what type of compound means here physical adsorption compounds only Freundlich adsorption isotherm is applicable. Next one, Langmuir adsorption isotherm. Before the discussion of Langmuir adsorption isotherm, what we are discussing about that? Langmuir adsorption isotherm is for chemical adsorption phenomena. In that Langmuir adsorption isotherm, we have to take, this is the surface area. In every metal surface area, will having fixed sites are present. In every metal surface area, will having fixed sites are present. On that fixed sites, whatever the atoms or molecules are accommodated. So, like this, whatever the surface area, on this surface area, the fixed sites are present, that is called interstitial places will be there. On that interstitial places, the atoms or molecules are covered. The atoms or molecules are covered. The covered area we can representing as theta. Covered area we have to representing as theta. Uncovered area we have to representing as 1 minus theta. Means adsorption is phenomena. What type of phenomena? Adsorption is a surface phenomena. And at how much depth it will be takes place? 100 nanometers depth it will be takes place. For example, this one is the metal surface. On the metal surface, the covered area is theta. This part is covered area. This part is uncovered area. Uncovered area, this total volume is 1 volume, it will be takes place. The uncovered area we have to represent 1 minus theta. Theta means covered area, another empty space is called as 1 minus theta. Now, here Langmuir adsorption isotherm, Langmuir adsorption isotherm is phenomenon for what type of adsorption? Is a chemical adsorption. According to the chemical adsorption, every metal surface or solid surface will having the fixed sites are present. Fixed sites means, I think you know very well of Chinese checkerboard. Game ఉంటుంది కదా, Chinese checkerboard. In that game will having the, you have to use different type of balls. In that small holes it will be there. In that holes, every hole will having the fixed site. And that like that atoms are fixed site it will be there. The atoms does not interact with each other. There is no attraction, there is no repulsion in that particular place. ఇండివిజువల్ చైర్స్ ఉన్నాయి అనుకోండి, బెంచ్ అయితేనే పక్క పక్కన కూర్చుంటారు. బెంచ్ కాకుండా ఒక క్లాస్ రూమ్లో ఇండివిజువల్ ప్లాస్టిక్ చైర్ స్ట్రక్చర్ అట్లా ఉందనుకోండి, ఒక చైర్లో కూర్చున్న పర్సన్ ఇంకో చైర్లో కూర్చున్న పర్సన్తో ఇంట్రాక్షన్ ఉంటుందా అంటే దెర్ ఇస్ నో అట్రాక్షన్, దెర్ ఇస్ నో రిపల్షన్. సో లైక్ దట్ ఎవ్రీ మెటల్ సబ్స్టాన్స్ or every solid substance will have the fixed sites are present. On that fixed sites, atoms or molecules are deposited. When in that particular place, there is no attraction, there is no repulsions in that particular atoms and space. So that is the what about the covered surface area, what we have to see that. So on that metal surface, if gas particles are deposited on the surface area, it will be form one single layer. ఇప్పుడు అన్ని ఒకదానికి ఒకటి పక్కన డిపాజిట్ అయిపోతే it will form single layer. There is no form the multiple layer because of there is a chemical bond attraction in between metal surface and particles, like either nickel, palladium, platinum is metal surface, on that hydrogen gas is deposited. Like that, whatever the materials are in the fixed attraction force, it will be takes place. So like that, what we have to represent, that is the solid surface. On the solid surface, the area is covered area is representing as theta, uncovered area we have to representing 1 minus theta. Each side having the single molecule. At adsorption is consideration. Adsorption consideration is the equilibrium process. Equilibrium process means it is one molecule is continuously formation. At the particular state, what happen? Rate of adsorption, equilibrium process means what? First of all, adsorption will be takes place. After the adsorption, what happen? Again the molecules are coming, desorption is also takes place. It means it called as rate of adsorption is equal to rate of desorption. Rate of adsorption is depends on rate of desorption. Means rate is depends on what happened, what is the covered area. Rate is depends on covered area. And which covered area? Rate is depends on what we have to represent covered area. So that is the reason rate of evaporation is equal to Kd into theta. Rate of evaporation. Rate of evaporation is directly proportional to Kd into theta. Means theta means that is covered area. When evaporation will be takes place means that is D indicating as What about the dissociation? Dissociation means that is called as desorption. We have to say D is also desorption. Evaporation means escaped from the surface of the molecule. ఎక్కడి నుండి escape అవుతాయి? Covered area నుండి escape కావడం జరుగుతుంది. So rate of evaporation is directly proportional to theta. Rate of evaporation, if you write directly, rate of evaporation is directly proportional to theta. Rate is directly proportional to covered area. Rate of evaporation, evaporation is also called as desorption. Desorption is directly proportional to theta. Why theta? Evaporation, where it will be takes place? On covered area only it will be takes place. If you remove off the proportionality sign, rate of evaporation is equal to Kd into theta. D indicates desorption. Desorption means elimination. Next, rate of adsorption. Rate of adsorption is directly proportional to uncovered area. Means rate is directly proportional to uncovered area. Uncovered area, which factor is also involved? Pressure factor is also involved. If you create the pressure, that is what over the uncovered area. Uncovered means this one area is called uncovered area. Next, rate is directly proportional to P. P is directly proportional to uncovered area we have to represent. So that is also we can representing as rate of condensation is equal to rate of condensation. That is also called as rate of condensation is equal to Ka P1 minus theta. A indicating as adsorption. Condensation means molecules are closer to each other, that is D indicating as desorption, A indicating as adsorption, P means on that particular pressure only the molecules are closer to each other, that is uncovered area we have to represent 1 minus theta. So according to that chemical adsorption, rate of evaporation is equal to what happened? Rate of condensation. Rate of evaporation is equal to rate of condensation. So rate of evaporation is equal to rate of condensation means Kd theta is equal to Kap 1 minus theta. At the equilibrium condition what happened? Rate of evaporation is equal to rate of condensation. Rate of evaporation is equal to rate of condensation. If this equation is 1 and if this equation is 2, that is Kd theta is equal to Kap 1 minus theta. Now what we have to represent here? We have to calculate the theta process. So theta is equal to this Ka and Kd is there. Theta is equal to what happened? Ka P 1 minus theta by Kd. So that one representing as Ka by Kd. Ka by Kd we have to representing another constant, that one is B. Because of A indicates adsorption constant, D indicates desorption constant, both are the constant. These both constants we have to represent another constant, that one is B. So the theta is equal to what we have to represent? Bp plus 1 plus Bp. Now this is what about the representation of the condition, where delta theta is equal to Bp by 1 plus Bp. Now theta is equal to in the earlier what we have to represent? That is covered area we have to represent. Covered area means here this is the solid surface and these particles are deposited. According to Freundlich adsorption, what we have to say is x mass of the material means x mass of the gas material deposited, m mass of the adsorbent. So theta is equal to what we have to represent? X by m. Theta is equal to what we have to represent? X by m. Why we are representing x? X, what about this here? X mass of the x amount of the gas is deposited, m mass of the adsorbent. So that is the reason what we have to represent here, theta is equal to x by m. X by m is equal to k into Bp plus 1 plus Bp. X by m is equal to k into Bp by 1 plus Bp. So this one is according to the representation. According to the Freundlich adsorption equation, what we have to say? X by m is directly proportional to P. That proportional sign, if you are remove of this, x by m is equal to k into P. X by m is equal to k into P. So that is the reason x by m is equal to k into Bp plus, that P means what happened here? Bp plus, that P indicates as Bp plus 1 plus Bp. B is one constant, P is the pressure and X is the gas material, M is m mass of the adsorbent. Now here one more constant is there, one is K is constant, B is constant is there. So that K into B we have to represent another constant, that another constant is A. K is one constant is there, B is another constant is there. These both constants if you are representing, x by m is equal to AP by 1 plus Bp. So this is what about the Langmuir adsorption isotherm according to the phenomena. Here X means mass of the gas absorbed, M is adsorbent, and A is equal to what about the constant? What is the constant? K is K into B. K into B, that is we are representing another constant. Next, here the Langmuir adsorption that is above equation is called as Langmuir adsorption equation. We have to represent according to the condition, that is P indicating as pressure. So, what is the difference between the Freundlich adsorption isotherm and Langmuir? Here isotherm, iso means same temperature, thermal conditions. In that condition, physical adsorption is chemical adsorption. We have both phenomenons are there. In that both phenomenons, to how much amount of the material is deposited, how much area we have to cover, that will be discussed about the Freundlich and adsorption. Here high pressures is also what about the Langmuir adsorption thing. If you are creating the pressure at the equilibrium state, what we have to represent? Rate of evaporation is equal to rate of condensation. Now, according to that is a single layer formation, whereas Freundlich adsorption isotherm is a multi-layer formation, it will be takes place, and is a high pressure condition, it will not be applicable. But whereas if you creating high pressure or high, whatever the temperature, it form only single layer. After the completion of all the surface layer, there is no further adsorption is takes place. How adsorption is takes place means after the desorption, means if this all the area is covered, then this molecule is ejected out. When that first molecules are ejected out, then only adsorption rate will be enhanced. That phenomenon is called Langmuir adsorption. And after that another theory is also there, that is Bett adsorption isotherm. Bett means Brunner-Emmett-Teller. This Brunner-Emmett-Teller is proposed another adsorption phenomena. Based on this Brunner-Emmett-Teller, that adsorption isotherm is multi-layer. Langmuir adsorption isotherm is chemical adsorption, is a single layer. Freundlich adsorption is a physical adsorption, and Bett adsorption isotherm is multi-layer system, it will be takes place. Next, adsorption from solution. Solution means here what we have to, here the gaseous molecule we have to representing P. In case of liquid molecules we have to representing as C. C indicating as concentration of the solutions. So, that is the what over the variation and variable factors of adsorption isotherm. First condition Freundlich adsorption isotherm, second condition is Langmuir adsorption isotherm. Once again I will explain that Langmuir adsorption, please carefully observe. Every molecule will having the fixed sites are present, that is the first point. Every molecule or every whatever the solid substance will having the fixed sites are present. On that fixed sites only either gas molecules or whatever the liquid molecules are deposited. When it will be deposited, if all the surface areas are fulfilled, automatically that condition is called equilibrium condition. If you are applying the pressure or applying the more gas particles, that whatever the sum of the molecules are ejected out, remaining molecules are deposited. So, that is called as rate of evaporation is equal to rate of condensation. So, here the solid substance, the total unit area we have to representing as 1, covered area, the molecules covered area representing theta and uncovered area representing 1 minus theta. On that covered area only evaporation is takes place, uncovered area adsorption is takes place. Uncovered area adsorption is takes place, and empty ga unna place lo molecules vachi deposit avutayi. Empty ga lane place ante artham enti covered area nundi em avutayi molecules eject kavadam jarugutayi. So, that is the reason covered area and uncovered area. So, rate is directly proportional to covered area. If removal of this proportionality sign based on that, that is called rate of evaporation is depends on covered area. This is called as covered area. Covered area representing as theta. Removal of the proportionality sign, rate of evaporation is equal to Kd into theta. Here removal of the proportionality sign, that is the constant. D is called desorption and T is covered area. Next, uncovered area means based on the pressure, the adsorption is takes place, rate is directly proportional to uncovered area and pressure. So, rate of condensation is equal to removal of the proportionality sign Kap into 1 minus theta. So, at the equilibrium state what happened? Rate of evaporation is equal to rate of condensation. So, that is the reason rate of evaporation is Kd theta, rate of what about this adsorption or this is called condensation is equal to Kap 1 minus theta. Ka theta is equal to Ka by Kd, Ka by Kd, both are the constant, both constant we are representing another constant, that representation term is I am representing B. So, Bp by 1 plus Bp. Next, theta means what about the covered area? Covered area means X amount of the gas deposited, m mass of the adsorbent. X mass of the gas deposited, m mass of the adsorbent. So, that is the reason X by m is equal to, that is over the Langmuir equation, X by m is equal to K into P. So, X by m is equal to K into Bp by 1 plus Bp. Here K is one constant, B is another constant. These both the constants we are combining together, we are taking another constant, that is A. So, again X by m is equal to Ap by 1 plus Bp. So, this is what about the derivation of Langmuir adsorption isotherm. Means according to X amount of gas deposited, m mass of the adsorbent is equal to Ap by 1 plus Bp, depend upon the pressure factors, it will be variable. Next, if you are increasing the temperature, what happens? The rate of adsorption is also increases. Next, another one is applications of adsorption. Applications of adsorption, in that first of all production of high vacuum. Applications means where adsorption we have takes place. The generalized adsorption means the simplest way adsorption. If any wound will be there, in that if you go for any doctor, if any skin allergies or any whatever the wounds are developed on the body, what we have to use? We have to use either that is powder material or ointments we are using. That ointments we have to what about this placed on the surface where the wound is there, where the what about the material is damaged on that skin particular area, on that we have to apply the ointments. The ointments we are applied on the surface, the ointment applied on the surface. So, the medicinal area is also adsorption phenomenon is also using, and using the cold creams. Cold creams means in that summer area or in that winter area we have to use, and that skin allergies we are using cold creams. That cold creams also we are using and applied on the skin. On the skin means that is surface area only applying, that phenomenon is also adsorption phenomenon. Means in the medicinal part we are using the adsorption phenomenon. Next, another one is gas mask. Gas mask means generally in the coal mines we are using that. This gas mask, or in case of high traffic areas we are also using gas mask. The gas mask means having the different type of filters it will be takes place. Gas mask means that persons those who are having that what about this underground mining. Underground mining means coal minings. In that coal minings will having the heavy gases will be there, and carbon oxide gases like carbon monoxide and carbon dioxide, like that poisonous gases will be evolved in that in the mining of the coal. In that particular purpose, if that carbon monoxide gas or carbon dioxide gas if inhaled to the body, it converting as carboxyhemoglobin. So, carboxyhemoglobin is decreasing the percentage of oxygen, it causes to what over the death also. To overcome that, what they are using, that mining people they are wearing the gas masks. That gas masks filter the what about the poisonous gases. Filtering, what word we are using? Filtering. Filtering means automatically that is protected from those particular gases. So, that is called adsorption phenomena. In that gas mask several filters are using, that filters are preparation of the pure oxygen purpose. Next, high vacuum pressure. Creation of vacuum means that is best example for that. If you purchase any water bottles or any what about the new bags or what about the trousers, it will be there. In that they are using one small bag, it will be there, one solid bag it will be there, where if you are buying any shoes or whatever it may be, in that one sachet, small sachet it will be there. If they are written as what over the, it's a poisonous, throw away. Means why they are using, if you are purchase any water bottles, in that if that materials will absorb the gases, that is silica material and alumina materials are present. That silica materials and alumina materials, is there any gas particles are present in that container, that will be having absorbed that. Due to the adsorption, it will be keep on dry. When it will be dry is there is no fungus development, or there is no what about the odor development, it will not be takes place on that particular. So vacuum generation is also we are using that application of the adsorption, and medicinal industries and gas masks also we can using that. Next, removal of coloring matter from solutions and heterogeneous catalysis. Removal of coloring material. Colored materials means every solution will having different colors will be there. For example, potassium permanganate will having the violet color, and potassium dichromate will having the orange color, it will be there. Nickel compounds will having green color, it will be there. Like copper compounds are blue. Every compound will having the some of the color agents are there. If we are adding some external particles of the material, the color intensity will be decreases. This material, when you are adding the material, either charcoal material or activated charcoal material, if you are added, those color compounds are deposited on the surface. For example, if you are added in that colored solution, either chalk piece, whatever it may be, the colored pigment is absorbed by the material, automatically intensity of color will be decreases. So this is also one of the phenomenon of adsorption. Another one is different type of application in the preparation of Cantock process, that is sulfuric acid preparation. In the preparation of Haber's process, ammonia preparation is also there. There also we are using different type of catalyst we are using, that is contact process, vanadium oxide and platinum, and Haber process iron catalyst we are using. So that catalyst act as whatever the adsorbate areas, and the materials are deposited on the surface like that nickel material of this compound. So this phenomena in the preparation of different type of compounds, the catalytic materials is also carry forward the different type of elements. That phenomenon is also belongs to adsorption phenomenon. Next is separation of inert gases. This is the topic present in the first year level. Inert gases mean helium, neon, argon, krypton, xenon, radon is there. Of course, radon is a radioactive compound. Even the separation of inert gases. Inert gases means these all the gases are present in the atmosphere. So if you are whatever the collect the material, after the collection of material, again we have to separate helium, neon, argon, krypton, xenon, like that separation. Take those all the gases. One experiment is there, that is Dewar's experiment. That is called as Dewar's flask. That Dewar flask will have the U-shaped tunnel, it will be takes place, and U-shaped pot it will be takes place. In that, whatever the charcoal is filled. So like this, whatever the pot it will be takes place. These are the series of connections it will be takes place. Here also one whatever the flasks, like this several Dewar's flasks are like this, it will be connected. Like this, different type of flasks are connected. These are one material is connected with another, another material is connected another, like this. Now, if you are these all will be having closed, in this we will have the different type of sized charcoal particles are present. Different type of sized charcoal particles are there. So here activated charcoal materials. Activated means in the dry condition, if you are taking, there is no moisture in that, automatically in the dry condition more adsorption phenomenon it will be takes place. And different ranged means that is size of the material or porous nature of the materials are we are into the placed into the charcoal compounds in the flask. Now if you are passed the noble gases into the Dewar's flask, the gases will be enters into the first flask. After the first flask, based on the size factor of the charcoal material and gases particles, some of the gases will be absorbed, remaining of the ejected into the another gas. Like this, based on the size of the charcoal, based on the size of the noble gas material, it will be separated in one chamber. First chamber will have the heavy dense particles are deposited, and after the next next like that. And means, for example, here xenon and argon, here krypton and neon, and after that helium will be ejected out. Like that heavy particles are first deposited, then only after that and after that. After deposition of the charcoal material, then we can disconnect the component and heat the materials of the charcoal, then we can collect the separation. So adsorption phenomenon is also useful for separation of noble gases. This experiment is done by Dewar's scientist, so that is called Dewar's flask experiment. So in this phenomena, which material we are using? Activated charcoal material. On that activated charcoal, the gases will be deposited. After the deposition, what we have to do? We have to heat the material, the gases will be ejected out. So that is also one of the phenomenon of adsorption phenomenon. Next one is dyeing of cloths. Another adsorption phenomena, dyeing. So, dyeing means here cloth dyeing. Cloth dyeing means printing of the materials. Some of the whatever the garments it will be there, on the garments the different colored components and designs are whatever the print on the surface. That phenomenon is also whatever the adsorption phenomenon. Next, another one is softening of hard water and ion exchange process. Softening of hardness water and ion exchange process. This is also you know very well in the first year, that is first group of elements, purification of water in that zeolite permitted process is there. Ion exchange process, another one is whatever the softening of hardness of water. Two methods are there in that ion exchange process we are using. In that ion exchange process, two containers will be there. I think you know very well that will be purification of water, that is 100% pure water we are collecting here. In that we will having that one is another connection it will be there. Here one whatever this bed is present, here also another bed is there. One is cation chamber, another one is anion chamber. When we are passing that hard water here, all cations are whatever the filtered off, and when we are passing this water here, all anions are filtered off, and we can collect that pure water here, that is H2O we are connecting that. So, here adsorption phenomena. Here adsorption phenomenon means this one is cation exchanger, this one is anion exchanger. Cation exchangers and anion exchangers are made by poly compounds. Poly means is a organic polymers it will be developed, and cation exchangers are developed by alkyl group of the compounds and sodium compounds, and anion exchangers are developed by whatever the hydroxy groups and acid groups and phenolic groups it will be developed. So, those filters are exchange the cations. What are the cations are? That is calcium ions, magnesium ions, majorly calcium magnesium ions are present. That anion exchangers are chlorides, sulfates and nitrates, chlorides, sulfates and nitrates, and as well as bicarbonate materials. Bicarbonate material. So, these are the whatever the materials are causing for hardness. These are the materials for causing for hardness. So, if any material will having bicarbonate is present, those bicarbonate materials are temporary hardness causing salts. If chloride, sulfate, nitrates are present with any of the cation, those materials are permanent hardness causing salts. Permanent hardness causing salt. How it will be means, for example, that is calcium chloride, if react with that compound calcium sulfate, another one is calcium nitrate. So, these are the materials, and if they react with magnesium compound, magnesium chloride, and this one is magnesium sulfate, and this one is magnesium nitrate. So, these materials are whatever the permanent hardness causing salt. These materials are permanent hardness causing salt, and another one is calcium bicarbonate and magnesium bicarbonate. These materials are temporary hardness causing salt. These are temporary hardness causing salt. So, these cations are exchanged and anions are exchanged in this particular area. So, these materials act as adsorption agent. At the same time, zeolite permitted process also. Zeolite means that is the chamber it will be there, that is zeolite bed it will be there. In this zeolite bed, that is K2SO4, Al2SO4 materials are present in that zeolite, Na2O, Al2O3, XSiO2, sodium oxide, Na2O, Al2O3, XSiO2 and YH2O. Like this, whatever the combination it will be there. In that natural zeolite is, that is natrolite material. Natural zeolite material is natrolite material. These materials are that zeolite bed, only cation exchange will be takes place. Cations are filled form. And whereas ion exchange process, cation is also filtered off and anions is also filtered off. So, that is the whatever the major advantage, and this phenomenon is whatever the adsorption phenomenon is. Next, surfactants. Surfactant means emulsifiers. Emulsifier means oily compounds is also whatever this added. By adding the oily compounds, those less dense particles are attracted, or the particles will be deposited on the surface area by adding emulsifiers or surfactant, and that process is called in fluorescent flotation process. And another one is chromatographic analysis. Chromatographic analysis. Chromatography means that is also phenomenon of adsorption phenomena. For example, the simple example in the biology students, if you have understand that, if we take any leaf, that leaf will have the several pigments are present, several components are there, and take that leaf material and grind it. Take that leaf material and grind it by using any solvent. The solvent means either ether solvent or CCl4 solvent or benzene, whatever the solvent, and the grind the leaf part. Leaf తీసుకొని దాన్ని గ్రైండ్ చేసేయండి. గ్రైండ్ చేసినాక you can take that paste and take the chromatogram. Chromatogram means like this, it will be paper, it will be there, and take 1 centimeter distance of, make a mark 1 centimeter distance, and after the grinding of the leaf material, take the part and make it a spot. లీఫ్ మెటీరియల్ తీసుకోండి, లీఫ్ని ఏం చేయండి, గ్రైండ్ చేయండి. గ్రైండ్ చేసిన తర్వాత పేస్ట్ వస్తుంది, ఆ పేస్ట్ను స్మాల్ డ్రాప్ తీసుకొని ఇక్కడ 1 సెంటీమీటర్ డిస్టెన్స్తో ఉన్నటువంటి క్రోమటోగ్రామ్ అంటే క్రోమటోగ్రఫీ పేపర్ పైన ఆ మెటీరియల్ పేస్ట్ చేయండి. చేసి దిస్ విల్ బి పిన్డ్ అవుట్, పిన్ చేసేసి అండ్ ప్లేస్డ్ ఇన్, పిన్ చేసి దిస్ విల్ బి ప్లేస్డ్ ఇన్ వాట్ ఓవర్ ద డిప్ ఇన్ టు ద ఎనీ ఆఫ్ ది సాల్వెంట్, డిప్డ్ ఇన్ ఎనీ సాల్వెంట్. ఇక్కడ మనము మెటీరియల్ మార్క్ చేసాం, ఇక్కడ వరకు ఫిల్ అయ్యేటట్టు ఒక హాఫ్ ఆఫ్ ది పార్ట్ ఫిల్ అయ్యేటట్టు సాల్వెంట్లో డిప్ చేయండి. దిస్ ఈజ్ ద క్రోమటోగ్రఫీ పేపర్ అండ్ హ్యాంగ్ ఆన్ ద in the beaker, hang in the beaker. The beaker is what about this, filled with any of the solvent. The solvent is either CCl4 solvent or in case of benzene solvent it will be there, in that you can hang out. After that what happen, the solvent is absorbed the chromatography paper and it will be what over the raising the solution. When the solution is raises in the upward direction, automatically the material is also moving from upward direction, and after the it will be reached in the top level, then remove the chromatogram and dry the chromatogram. After drying, what you have to observe, you can observe different type of spots you are observing and different type of colors you are observing. Based on the colors or based on the spots, this much of components, this type of components or these many number of components are present in the particular material. This phenomenon is also what type of phenomenon? Adsorption phenomenon. Means the different type of compounds are present on the what about the surface of the chromatogram. That is also phenomenon of adsorption. Next, these are the what about the adsorption applications. These are the phenomena of adsorption applications. Now, another one is catalysis or catalyst. Another topic is catalysis or catalyst. Here, you can observe that catalysis and catalyst. Catalysis means cata means wholly, lysis means loosen. The first given by this catalysis, Berzelius scientist. This catalysis, by using the different type of catalyst, different type of compounds also formed. Here, the catalysts are two types of catalysts are there. What is meant by catalyst? Catalyst means the rate of reaction enhancing property is known as catalyst. If you enhancing the rate of reaction, that property is known as catalyst. Here, how catalyst will be acted? If you take any reactant, the reactants are converting as product. Generally, every reaction, the reactants are converting as product, that is called as reaction condition. In this condition, what we are doing here, to enhance the rate of reaction, what we are using here? Catalyst. What we are using here? Catalyst. These catalysts are two types of catalysts are there. One is positive catalyst, another one is negative catalyst. One is positive catalyst, another one is negative catalyst. Positive catalyst means rate of reaction is enhancing phenomenon is known as positive catalyst. Rate of reaction is decreasing phenomenon is known as negative catalyst. So, for every reaction, now this one is here reactants are there, this is the product. Every reaction like this one graph it will be there. Every reaction you can take one graph it will be there, and this particular point is called activation energy. This particular point is called activation energy. If any reactant cross this particular point, then it will be converted, product is converted. If any reactant cross this area, it converting as product. This particular point is known as activation energy. This particular point is known as activation energy. If if any reactant will having some amount of whatever the energy is present, this is called normal energy. Every reactant will having some amount of energy, that energy is called as normal energy. So, after that normal energy, when it will be reached that activation energy, then only it will be converting as product. If that molecule does not reach that activation energy, the molecules does not converting as a product. So, to reach that activation energy, either we are using temperature for liquid solutions, or in case of gaseous material we are using pressure. Why we are using temperature and pressure? To reach that activation energy, because of all molecules does not having that energy to reach the activation energy. Only some molecules reach the activation energy, then only they are converting as product. How that will be reached? By the collisions. By the collisions it will be reach the activation energy. ఏ మాలిక్యూల్ అయితే యాక్టివేషన్ ఎనర్జీని రీచ్ అవుతుందో అదే ప్రోడక్ట్ అవుతుంది. యాక్టివేషన్ ఎనర్జీ రీచ్ కాలేదు అనుకోండి, ప్రోడక్ట్ కాలేదు. మరి యాక్టివేషన్ ఎనర్జీ రీచ్ కావడానికి ఏం చేయాలి? సొల్యూషన్ హీట్ చేయాలి. సొల్యూషన్ హీట్ చేసినప్పుడు ఏమైతుంది? మాలిక్యూల్ మధ్యలో కొల్యూషన్స్ ఇంక్రీజ్ అవుతాయి. వెన్ మాలిక్యూల్ కొల్యూషన్స్ ఆర్ ఇంక్రీజ్డ్, దీస్ ఆర్ కన్వర్టింగ్ యాజ్ ప్రోడక్ట్. If there is no collisions, there is no product formation. In case of gas molecules, what we have to do? We have to give in the pressure. When we are giving the pressure వల్ల ఏమవుతాయి? molecules are closer to each other. When molecules are closer to each other, automatically materials are converting as product. So, here what is the using of catalyst? If you are using the catalyst, activation energy either decreasing or increasing it will be takes place. So, based on the decreasing and increasing, the catalysts are two types. If you are using positive catalyst, the reactants are converting as product, the activation energy will be decreases. This is the actual point. If you are adding the catalyst, what type of catalyst? If you are adding positive catalyst, by adding the positive catalyst, what happened? The activation energy barrier will be decreases. When activation energy barrier is decreases, automatically the rate of reaction is enhanced. In case of you are adding negative catalyst, this one is reactants and these are the products condition it will be take. By adding negative catalyst, the activation energy barrier will be increases. When activation energy barrier is increases, rate of reaction is decreases. Generally, the reaction graph like this it will be takes place, any reaction. After that, what happened? What I am doing to enhance the rate of reaction? I am adding catalyst. What type of catalyst I am adding? Two types of catalyst I am adding. That is, one is positive catalyst, another one is negative catalyst. By adding positive catalyst, activation energy barrier will be decreases. By adding negative catalyst, activation energy barrier will be increases. When activation energy barrier is increases, automatically reaction will be stops. When positive catalyst is there, automatically reaction proceeds speed. So, this is called as whatever the catalytic function and catalytic property. Some of the autocatalysis is also there. Autocatalysis means when reaction takes place, in that reaction either whatever the more number of electrons are released, that is called as either oxidation reactions, or in case of reduction reaction, some amount of energy will be liberated by the releasing of the electrons. By releasing of the electrons of the oxidation and reduction reaction, by using the reduction reaction, the energy will be liberated. Based on the liberation of energy, the rate of reaction will be proceeds. That is called autocatalysis. And catalytic function will be enhanced. Catalytic function is also enhanced by adding some external materials. Those are called promoters. By adding by enhancing the speed of the catalyst, adding external materials are called as promoters. So, here the promoting materials are maybe loses in that another different type of components, and finely divided materials, finely means powder form divided materials is also catalytic function is enhanced. Another catalyst also there, positive catalyst, negative catalyst, additive catalyst, another one is biocatalyst. Bio means it is a biological functions. What are the biological functions? In our body, digestion of food materials or taking of the food materials, processing, different type of biological function it will be takes place in the body. If any bacterial or any viral materials are enter into the body, automatically the generation of fever will be takes place. By the generation of fever, you cannot take the food materials whatever in that proper way. So, means the bio function will be disturbed. So, biofunction will be disturbed, that is called as whatever the catalytic property. Biocatalyst means that is also the best examples are enzymes are biocatalyst. Enzymes are biocatalyst, that is pepsin enzyme, trypsin enzyme, and these are the different type of enzymes are present in our whatever the biological. If the body temperature is enhanced, the biocatalytic property will be decreases. Majorly I can observe that biocatalyst means in our body regular functions, what are the enzymes are using, that is called as biocatalyst. If that biocatalytic function will be decreases, when it will be decreases, the biocatalytic properties decreases by the temperature will be increases, means if the body temperature increases, automatically catalytic function will be decreases. So, another one is here, another is also there, that is called as specificity and selectivity of the catalyst. In that specificity and selectivity of the catalyst, if we take carbon monoxide and hydrogen, this carbon monoxide and hydrogen both are react with each other to form methane plus water. This is the one reaction. And carbon monoxide plus hydrogen, these are react with each other to form formaldehyde, This is the product condition. So, carbon monoxide plus hydrogen, both the reactions if you are observing, the reactants are same, but the generation products are different. Carbon monoxide and hydrogen reacts with each other to form methane molecule. Here, whatever the methane molecule is there. So, here the balancing of the chemical equation, here one carbon is there, one carbon, and how many hydrogens are there here? 4 plus 2, 6 hydrogens are there. If I am using here 3 to the 6, and how many oxygens are there? One oxygen is present. Now, see that is the reaction is balanced. One carbon is there, and what about this? 4 plus 2, 6 hydrogens are there, and one oxygen is there. Now, here carbon monoxide plus 3 moles of hydrogen is reacts with each other to form methane and water. This ratio is what type of ratio? 1:3 ratio. Now, if you see the second reaction, reactants are same. Of course, what about this? Coefficients are different, but here reactants are same. Here carbon monoxide, here also carbon monoxide. Here the reacted material hydrogen, here also reacted material hydrogen. The generated product is formaldehyde. This generated product is formaldehyde. Now, how many carbons are there here? In the reactant, one carbon is there, and product is also one carbon. In the reactant, 1 molar, 1 atom oxygen is there, here also oxygen, and 2 hydrogens, 2 hydrogen. Both the reactants are same, the products are different. In this condition, how it will be variable means, in that first reaction, the condition we are using the catalyst, nickel catalyst we are using. In this condition, we are using copper catalyst. This is called selective catalyst. Positive catalysts are there, negative catalysts are there, and another one is biocatalysts are there, another one is autocatalysis is also there, another one is what over the selective catalysis. Selective means reactants are same, but products are different. On what condition? Reactants and products are variated by using the catalyst. Nickel is also catalyst, copper is also catalyst. The catalytic power based on the releasing of the electron power and nature of the catalytic material, both are the d block elements, and energy release functions, and based on the nature of the material functions, automatically product is also variable. So, that is called as selective catalyst, that is known as selective catalyst. Another one is hydrogen peroxide is also dissociated H2O plus O2. That is all in the catalyst is glycerol is the catalyst. Means by using the different type of catalyst, we can use the different type of materials. And another one is the catalyst again majorly classified by 2 types, homogeneous catalysis and heterogeneous catalysis. This will be discussed in the homogeneous, heterogeneous in the next. And now coming to that, what I am discussed today, once again I will reveal that, based on that thing you can what over the in that last class we are starting about the surface chemistry. Based on the surface chemistry, what we are doing here, different type of adsorption techniques we are discussing. After the adsorption technique, adsorption phenomenon, how it will be takes place, that is determined, and whatever the scientifically proven, scientists are 2 theorems are there. one is Freundlich adsorption isotherm, another one is Langmuir adsorption isotherm. According to Freundlich adsorption isotherm is a physical adsorption. The principle for Freundlich adsorption isotherm is log x by m is equal to 1 by n log p plus log k. Based on that thing, some of the applications are there, and this is for the pressure function. In case of solution function, in the place of p, what we have to substitute c, that is x by m is directly proportional to c to the power of 1 by n. If you are removal of the proportionality sign, x by m is equal to k into c to the power of 1 by n. There we are using x by m is equal to k into p to the power of 1 by n. In case of solutions, x by m is equal to k into c to the power of 1 by n, that is for Freundlich adsorption. This is for physical adsorption phenomena. Langmuir adsorption phenomenon, that is x by m is equal to ap by 1 plus bp, is belongs to chemical adsorption phenomenon. Chemical means the strong attraction forces it will be takes place in between two molecules, that is called as, what about this here, chemical adsorption phenomenon. Next one is, after that adsorption isotherms, then adsorption applications. Adsorption applications. What are the adsorption applications? Industrial applications are there, medicinal applications are there, and what about this? Some of the domestic applications is also there. What about the domestic application means purification of water, and industrial application means different type of preparation of ammonia, preparation of sulfuric acid, and dyeing of the clothes. These are they will be having in the paper industry, preparation of molasses, coloring agents, activated charcoal. These are the materials are present. And after that, catalysis is there. In that catalysis means to enhance the rate of reaction, to speed up the rate of reaction, the catalysis takes place. The catalysts are enhancing based on the enhancing nature. Generally, the metals act as a high catalytic power, it will be takes place. Majority conditions are metals, it will be takes place because of more number of electrons are releasing energy is also there, and interstitial places will be there. The molecules are readily attract on the surface area. And these catalysts based on the nature, positive catalyst, negative catalyst, autocatalysis and biocatalysis it will be there. And after that, what about this here? Selective catalysis is also there. Selective means reactant will be same, but product is variable. So these are the different type of what about the applications on the catalyst. And again, the further topic is what about this homogeneous and heterogeneous catalysis. Tomorrow we will discuss. Now what you have to do means just open your volume, and in that volume what the topic today we are completed on the topic, read the content and do the what about the modules in the level 1, level 2 it will be, and topic wise how to do, it's more easy for you for your convenience, because of this surface chemistry is a purely theoretical based. So that is the reason how to read, and at the same time how to read the textbook also and do the answers automatically is a simultaneously you will be completed. Thank you.